Hello, everybody. Welcome back to another episode of Table TechTalk, where we discuss interesting things that we find in the world of tech. Yeah, so we're the same guys. Basically, it's the same Niwas here, the same Sandeep Dai, same me, Gautam, and
the same Osti.
yeah. All right. So that's out of the way now. Okay, so what did we find interesting in the past month about some topics, you guys?
Yeah, about origami. I'm trying to make a beautiful crane out of paper, but I haven't been able to figure it out. So in Japanese culture, they say crane is very auspicious. And they have a saying that anybody who folds 1,000 paper cranes will have their heart's desire come true. Seems like it's not coming true for me.
So this is your first one. So you need
Yeah.
999 still more.
Yeah, seems so.
But
So,
yeah, Sandeep,
Yeah,
what-
talking about origami, it started in Japan something like 1,000 years ago, and origami actually means like ori means folding, and gami is about the paper. So it started as a religious activities back then when it was used for religious decoration or gift wrapping. Later on, it has been developed into recreational habits. But the origami popularity came only after when they started kindergarten. So in Japan, somewhere around 1875, they had first kindergarten, and one of the teaching, beside teaching, they also taught students how to fold papers. So origami actually came to Europe and towards the world when kindergarten became more popular.
And how did we end up doing that in Nepal? So I guess it went from Japan to the West, and the British education system brought it to India, and then back to Nepal, where we also ended up making those boats.
Yeah, we never knew about what is origami. I mean, like even for me, last week we discussed we were talking about the origami in this podcast, and I was saying why we are talking about origami. I mean, what does it mean? It's just a child
No,
play.
we did not plan talking about origami. We just came up with this morning when we saw Sandeep Dai was playing with some papers now.
Yeah, but the origami.
Back then,
I mean,
origami was just craft.
yes.
But in somewhere in 1950s, origami grandmaster Akira Yoshizawa. So he changed this dynamics of folding paper into art. So he developed some technique called wet folding, and then he started making stern-faced gorillas, baby elephants, and others. So this is how he also published first book about how to make different characteristics from origami or different animals. And then I think this was taken into science of folding papers. Now also in the mathematics and other fields, like for example, the car airbag in the car is folded using origami technique.
Or they were also in this biomedical engineering. I saw some videos they can fold all the equipments with the very small microscopic part, and then it goes inside your body, and then it unfolds, and then it can do quite intricate dissection of the operation. So
Yeah. Wait, wasn't paper invented in China?
Yes,
Yes.
that's what.
And then the Japanese took okay, we take your paper and we start folding it.
Yeah, so it's not just good enough for writing things on. You can apparently make art from it.
Those Chinese lamps, those are also kind of a
Yeah,
form of
we can
origami, right?
say that if anything related to folding paper is origami, then yeah, folding.
But isn't it now in this modern society? I guess it's not about only the paper, but it's more about how the folding is done, because
Folding everything.
folding can be for the metals or some carbon fibers or this kind of biomedical structures.
Yeah, so I think the most interesting thing for me is that there is this object like paper which is in 2 dimension, and you fold it and you convert it into some three-dimensional object, which is more useful.
So it has been used in antenna technology.
Yeah. So what I read somewhere was that this James Webb telescope. So one of the antennas was folded using this origami technique, and then when it went to the space, they unfolded the antenna. So well, there is something in my phone, and it seems like it has been these kind of techniques has been explored for a while, and then there is some rigorous discipline of mathematics, which I mean, it has this axioms, like the geometry axioms from geometry, and then there are these axioms from for origami, and then you can use these axioms to prove that what you can fold and make things, and what you can and cannot do. So it seems like you can using origami or folding papers, you can do constructions that are, or you can solve these third degree equation like this, not quadratic, but then degree 3 equations using these origami. So, and that's where the power seems to come from.
But it's interesting to see, like, I mean, it was not the mathematics who gave birth to the origami, but from origami came first, and then the mathematicians, like, re-studied, like, what is behind the origami, and they found some mathematics behind it. So,
yeah, but that's how things usually happen, right? So someone comes and discovers something practical, and then there are then people who say that, oh, why is it working? And then they start thinking about it, and then, okay, this seems like more general than what it seems to be there. So it is very interesting. So if you look at so I think it was the same video that I was talking about.
was it the antenna of this James Webb telescope or these glasses?
I think it was the solar.
It's not the
solar
solar
cells.
It's not the solar cells, but it's like.
Is it the lens?
It's a lens which collects the like a light.
Yeah, but then is it like glass lens? Because what I thought was that it was some sort of this microwave. It is collecting these microwaves and not just light. So isn't it like some sort of antenna, effectively?
That's what I thought.
I mean, it is not necessarily a glass.
But it's also it's used for, like, at least to capture the light, to take a picture of the, like, far.
But does it even take pictures of light? Because isn't it supposed to, like, collect these microwaves or something
like infrared,
even
infrared.
No, not in the spectrum of this visible light, but then somewhere like far.
Yeah, it's collecting, well, not light, but like in that electromagnetic.
No, it's
spectrum.
actually it's both the primary mirror, the sun shield, as well as other parts of wave that are designed to unfold in space. So basically, make it compressed enough to pack it more efficiently, and then it unfolds in the space.
It makes it more easier to transport, like when things are folded in a certain way, and then it is unfolded in a desired way. So it has been used for a wide variety of uses. Like I've seen one company called Oru Kayak. So it has designed this kayak based on origami technology. So you can fold this kayak in the small sheet, or carry it yourself and then unfold it and then go for kayaking.
Yeah, and then I have also seen like these maps, these huge maps. I think these are folded using this origami, and then you can just carry it around and then unfold it and look at them in some cities. So the folds are quite well defined. So I think those are these techniques, but it's so interesting because like
Now you made a ball.
Yes, I think this is what. See, the magic of origami. It was packed into
not
a very
just folding,
small
but you're pumping air into it as well. So it's more than origami now.
It looks like I haven't forgotten, doing this as a kid. So it packs into this small space, and now let's play a game of ball. And now, yep, here you go. All right. What else has origami been used for? So we covered the medical devices. What else can?
Well, I saw some videos also, like even like military are also using the origami techniques for making those bulletproof shields. So it's not about like the whole origami will seal the bullets, but it's like you have the material, and then once you make that origami fold, then it will be so strong, like you can just carry it, and then it can block like
Okay.
bullets.
That's nice.
Mostly used by the police.
Mosti sir, any other ideas about the origami?
No,
You want to add?
what was interesting to me also was this. It seems like there are these 7 axioms of origami that I read from Wikipedia. So it seems like I'm just quoting Wikipedia now. The first 6 axioms were known as Justin's axioms, or Huzita's axiom, and then the 7th was discovered by some other guy. But then the first one says that given 2 distinct points P1 and P2, there is a unique fold that passes through both of them. So if you have like 2 points on a piece of paper, then if you fold it, the fold is going to be unique, always. I mean, there can be only one fold that can be passed through these 2 points.
It's a definition of the line.
It's the axiom. So this is how you start defining things, and then then the second axiom is that given 2 distinct points P1 and P2, there is a unique fold that places P1 onto P2. So only one fold will put point 1 P1 over point P2. You can do it only in one way. Yeah. So these I mean, there are other things as well. Things start getting a bit complicated after that. So
what are these axioms then used for?
I think they use it to prove certain things after that. Like, so do you remember like what are the axioms of the Euclidean geometry?
Please enlighten us. Yeah, deep dive alert here. Sometimes we end up.
The interesting thing is that so I think not axioms. I think Euclid calls them postulates. So if you remember geometry from school, so we have 5 postulates that comes from Euclid, and then based on that we start proving all these theorems based on that, and then even this Pythagorean theorem follows from these postulates, right? So if you search Wikipedia about Euclid's postulates or axioms, then you will see that like there are 5 of them, and then they look deceptively simple. So can we have something on the screen?
Yeah.
So just a statement of these 5 Euclid's postulates. So for let's say plane geometry.
So here it says.
The Euclid postulates. If you look at them or if you read them, the first one says that a straight line segment can be drawn joining any 2 points. I mean, that sounds very reasonable, right? And then the second postulate says that any straight line segment can be extended indefinitely in a straight line. No, nothing there. And then number 3 postulate is that given any straight line segment, a circle can be drawn having the segment as radius and one endpoint as center. I mean, you have 2 points. You can bring a compass, put like the point there, and then put the tip of the pencil in the other one, and you can just draw a circle on them. And this is like how he starts. I mean, this is very reasonable things, right? And then number 4 says that all right angles are congruent, which means that they are the same. They are one and the same. But then look at the 5th one now.
Where is the 5th one?
Yeah, the 5th one is very interesting. So 5th one is not this simple anymore. And this is like, I mean, I can go on and on about it, but then all these interesting things happen from it.
Wait, let me find the 5th one.
Yes.
Just a sec. Yeah. If a straight line falling on 2 straight lines makes the interior angles on the same side less than 2 right angles, the 2 straight lines, if produced indefinitely, will meet on that side on which the angles are less than the 2 right angles. Okay, that's a mouthful.
That's a mouthful. But if you start thinking about it, I mean, it does make sense. So what it is saying is that you have 2 straight lines somewhere in space, and then a third line comes and then intersects them, right? And then how things happen is that, so on one side of this intersecting line, so there are these 2 internal angles. So what it is saying is that the lines are going to meet. I mean, this pair of lines are going to meet where the sum of these internal angles is less than 90 degree. And then it is not going to meet on the other side.
So this is we're saying that these won't be parallel lines.
Yeah, not parallel lines, yes. Yeah, so this is called the Euclid's parallel postulate.
Yeah.
And then it has very interesting history.
If it is parallel, they will never meet
Never
indefinitely. But if the point is like if it's not parallel, they will meet on the side on which the sum
is less than 90 degrees.
Yeah.
It will meet only in the sign where it is less than 90
Some
degrees.
is it like alternate angles?
No, the interior angles.
Interior angles.
But isn't it like addition of those interior angles is always 180 degree?
No, but then they should be parallel in that case. I mean, the lines can be, if they are parallel, then that is the case. And this is just in the case of Euclidean geometry. So if you relax this postulate, and then
the
start
sum
messing
should
them.
be less than 180.
Yeah.
Sorry, not less than 90, but less than 180.
Yeah, but then adding the third angle will make it 180. So two right angles, it's what it's saying there. Yes, not 90 degrees, but then two right angles.
Yeah, we have been proving this kind of axioms in our school time.
Oh,
Yeah,
the
but then
vertically opposite angles and all those. Yeah, now that's
Even
okay.
I remember like
Where's
like
that ball?
Yeah,
what is
yeah.
the alternate angle? What is the corresponding angle?
Yeah, but
what is the
these,
sum?
so
Yeah.
from these
Kids,
five
if you are
postulates-
learning, the high school geometry, this is the use case in life.
Yeah, but then the interesting thing is that from these five postulates, now all these theorems of geometry comes, like the sum of three angles of a triangle are 180 degrees, the Pythagorean theorem, right? I mean, if you put square on the two sides, two bases of a right triangle, and then add them, then it is same as the square on the hypotenuse. So everything follows from these with doing logical steps. But then it seems like they have also defined these similar postulates for origami, and then they have started to prove like something can be done and cannot be done based on that. I mean, it has been somewhat formalized in that sense as well. So that is also quite interesting.
Yeah, I think I stumbled upon this one video about this pigeonhole principle. So there was this, it sounded straightforward. So let's say if there's a pigeonhole with, n, pigeonholes, and there is n plus one pigeons, what it says is that when you put all of them there, there will be one hole where there will be more than one pigeons. So it's quite straightforward, like obvious. But the implication was that it was used to prove that if there are 5 points on Earth, then you draw a line between the 2 points, the other remaining 3 points, 2 or 3 will be on one hemisphere, something like that. So if there's 2 points, you can create a hemisphere out of it, and then the rest of the points will fall on one hemisphere. So I was like, that's interesting, because if you see that, it says that if you draw you can draw a straight line making all 5 points, random 5 points, fall on one particular hemisphere of the Earth. It's a pretty interesting application of a simple, obvious axiom that allows you to build other proofs.
Yeah. I think this pigeonhole principle is very interesting because I think you can prove many things in discrete mathematics using just this very deceptive principle, and it has been used in so many of these proofs that it seems so deceptively simple, but then you can use it to argue about more complicated things.
Yeah. Look at this structure. What does this remind you of?
I think you can.
Some crystalline structure made of carbon components. You know where I'm going with this. Looks like some diamond, structure.
Which are forever.
Are forever. Maybe I can give this to my wife and hey, the biggest diamond in the world.
I think she will be disappointed.
Yeah, but then this is mostly.
But then again, any
this is
diamond in the
mostly
world
carbon.
Yeah, and this is a carbon, mostly carbon with some impurities,
Yes.
and which makes it even better.
Yeah, diamond is mostly carbon, so you are not that far off.
But
So we were talking about this artificial or lab-grown diamond, to be precise.
So you're saying that
in 1797 they discovered that diamond is made of
carbon,
pure carbon.
and they thought like,
Okay,
that
why
means
can't
we
we
can't.
make
Yeah, there are other things that are made of carbon. So, Yeah, because they were. What I wanted to point out was that when they realized that this alchemy came from like these guys trying to make gold out of other things.
Lead, yes.
Yeah.
Yeah.
So similarly, so these other guys who thought like, okay, carbon, diamond, we can probably try to make it out of.
Yeah,
by
they have been
ourselves.
trying it for quite some time, and I think that there are like 4 different methods of making artificial diamond at the moment. So the very first one is this high pressure, high temperature technology, where they have some diamond seeds, which they expose to. This diamond seed is some graphite, which is also a form of a carbon. Then it's exposed to temperature like 1500 degrees centigrade, and they apply pressure like 1.5 million pound per square inch, and then you have a diamond.
And poof.
Yeah.
Yeah. Remember, I don't know if you guys did it in school. We had these pencils, those graphite lids. So that was also carbon. And then like, okay, in the organic chemistry class, then I was like, okay, this is a different crystalline structure of carbon, and the diamond is the same. If we press this enough, maybe I'll make diamond out of it.
Yeah, you need to
As a
press like
joke.
1.5 million pounds.
Yeah, but I think you need to break all these bonds.
Yeah, high
These-
temperature.
these-
High pressure, high temperature component was missing.
Yeah, the second method which is used is this chemical vapor deposition. So they have some sort of a chamber filled with carbon-rich gas and then heated up to 800 degrees centigrade, and you can see this carbon crystal grow. That's what they say.
So is it like worth to make this kind of like industrial diamonds, or does it get cheaper than the?
Well, I think so, because like India is racing to become one of the biggest artificial diamond producer in the world.
Yeah, I think there are a lot, because it is the hardest substance in known, right? So it has a lot of industrial use. So from that perspective, it is quite useful for various industrial use cases. But the question is, would natural diamonds be in abundance to satisfy all the demands for the industrial uses? And then we go into this whole area of the natural diamonds being artificially restricted, their supply being restricted, and hence the industrial or artificial diamonds taking the marketplace and having this market.
Yeah, I also heard or read it, like this kind of like industrial processes which to make these diamonds, they are getting more and more efficient, and then the cost of like making these industrial diamonds are getting half every 4 years.
Yes.
So, and also like though these industrial, of course, primarily it was made for like replacing those industrial diamonds.
Polishing.
Yes, but now they are also coming to this kind of like the market. For example, this kind of Valentine gift or this love, and also
as a gemstone.
As a gemstone, yes. And then in India, they are having very hard time to like detect like which one is the artificial and which one is the natural one, because
There are some experts, some carrier around like who can distinguish between a real diamond and artificial diamonds.
There's this De Beers has this institute that has they produce this diamond detection, grading machines. So they produce this kind of equipments that you can put in the lab to detect the clarity and the impurities there, to classify what grade diamond it is, whether it is synthetic or natural. Yeah, so they have this side industry for also detecting diamonds' qualities.
Why do we purchase diamond, or why do women like diamond, or how it came into existence like a gemstone? Do you have any clue?
Well, gemstones in itself,
Are
it's shiny.
Are they very rare? So is it because it's valuable because they are not like abundant, and that's
No,
why
but then,
it has
you know-
value. And then it's shiny, and then
Yeah, it is.
Yeah, it's basically ornamental use. Anything that is shiny, gemstones, pearls, all of these are used for ornamental purposes, and their value is determined by how rare those items are, right? And diamond came into that picture by being a rare item, and also its other properties of shining and all that.
Like archaeologists have found evidences like diamond were used somewhere like 2 million BCE for drilling other gemstones.
Mhm. So it was
It was used as a tool to make holes and
actually
things
that makes
other-
sense, because in nature, so makes sense, because in nature when you get the diamond, it's rough, it's not shiny at all, like some other, like pearl, out of oyster, it is shiny, but diamond, you get a very rough rock, and it's super hard,
and it is
so
the hardest substance.
it's the hardest substance.
Yeah.
And how do you cut it? It's there's this whole industry now able to do that, but in the early days, if you don't know how, it's just a rock that is not shiny, super hard. You can make use of it just to get
Yeah,
the
that
other shiny gems. Yeah, but once you are able to polish it, shine it into different cuts and designs, it is very shiny, reflecting lots of lights in different ways according to how you cut it, and that also takes a lot of skill. India has been doing this whole.
Yeah, until 1896, diamond was only available in India. Like they haven't found diamonds elsewhere. So in 1896 they found diamond mines in South Africa. So that's how this blood diamond things came.
So yeah, Africa has a lot of those resources, and there's a lot of other people's eyes when you have a lot of natural resources that the rest of the world can use.
That was also like because this British Emperor also has the diamond in her
Yeah.
in
So
her crown, so it's a kind of
the East
Crown
India
jewel.
Company, the during the shipping days of the European
Colonial
era. All these ships, they used to have these companies here going across trying to find valuable resources, gemstones, gold, any resource, spice and tea from India, and all those places, collecting them, bringing it back. So they had this whole stock market traded company that was their whole principle was like go abroad, find resources, bring it back for the betterment of the crown back home. And so from that regards, they were going across for all the other resources, and diamond was also one of them. They went for they collected all the diamonds also from India, Kohinoor being the prime example, and also I think they found in the African basin, or the Central Africa, there's lots of those, and then in the modern era, there's been a lot of conflict going on in those spaces, and then the concern was that the diamonds mined there were used. They would sell those diamonds to purchase arms and further fuel the conflict ongoing there. So it was called conflict diamonds. And yeah, Blood Diamond was the movie that portrayed that issue. But yeah, so that's kind of last time we also discussed about the lithium being discovered. It's like when having a valuable resource being discovered in your area does not necessarily end up being good for the people living in that area. The Middle East crisis, because oil was found there, or like diamonds in the other places, cobalt in Africa now. Yeah, Africa has been a bit fortunate in the sense that it has a lot of resources, but then not being able to gain the benefit, reap the benefit out for their own people is a misfortune.
Yeah. Has there been any market for the collecting the diamonds for like investment, like we do for gold?
I think diamond loses value, but there are some diamonds like bigger diamonds which never loses its value. Like
if they are like a modern art status, kind of like like a collector's item kind of. When it becomes a big collector's item kind of a thing with its backstory and history, like Kohinoors and those, from
Hope
the
diamonds.
Hope diamonds.
These Hope diamonds, they bring curse.
Yeah, but unless if it's that, then once you buy diamond from the market and you go back to the same shop tomorrow to sell it, I don't think you get.
Yeah, they come commercially available diamonds. They lose value pretty.
As soon as you buy it, it
Yeah.
loses value,
Unlike gold. Yeah.
which might appreciate.
What about the
value with
gold? You mentioned about this alchemy, like converting some lead to gold.
Yeah, I don't think that has happened. I think lead
that.
has.
Or
Gold
if it
is
has, then they
itself-
have,
itself
they
a
have
metal,
kept it a secret.
so-
Yeah.
Gold is itself a metal. So
Yeah.
what is it made of? Gold.
Yeah, gold is a primary element. Like
No. For example, you can do this kind of like nuclear fission or nuclear fusion to make, like, for example, in this nuclear fusion reactors, they are converting those.
Then we're talking
Yeah.
in the realms of everything in the universe is made out of hydrogen, right?
Yeah. You just take out like couple of electrons and you get the new metals.
Yeah.
Yeah, but useful things have come out with people trying to convert these lead into gold, right? The whole field of chemistry came up because there were these alchemists trying to convert lead into gold using some philosopher's stones or something, an experiment. So I think they have invented something more valuable than gold by trying to convert lead into gold. So and we also have, like, in our legends, like this Paras money, which converts
Whatever
these,
it touches is
whatever
into
it
gold.
touches into gold.
Yeah.
So there have been legends
a
and
King
Midas.
Midas.
yeah,
King Midas.
King Midas,
Yeah. Touch of gold. Hand of gold?
the golden touch.
Hand of gold.
Hand of God is Maradona.
yeah.
That's a different one. Yeah. Right.
So yeah, one final thing about talking about diamond or this artificial diamond is there's concept called memorial diamond, where you take parts of your human body, or even human body is made of carbon. So you extract something from your hair,
So you take a piece of my hair and then
extract carbon from it.
So you have to extract carbon from it separately and then put it into this high pressure, high temperature stuff,
Or some other
process. But then does that allow you to have the traceability in the sense that, okay, does the DNA information retain?
Well, I don't think it retains.
Probably
It's
not,
just-
right?
just
Once
a
you are
concept.
already extracting the atoms, you probably destroy all the,
Yeah, but it's
DNA.
now
Hey,
only
it's about
carbon.
the-
So DNA
Yeah,
has
memory.
many things except carbon,
Yeah.
right? So to make diamond, it has to be pure carbon, and then it has to be in some.
Let's say it's
Some shape
it's
like these
kind of
there.
a concept where so some of your loved one
Yeah, it's the
passed
memorial
away and-
diamond.
Yeah, but then there are these funeral houses who offer these services. So you just give them their body, and then they display it, and then the next day
Yeah,
they are
it's the
converted to
sentimental
diamond. Yeah.
value more of that that you need to think about. But I was just wondering if it would retain some sort of a signature of that person that you could trace back to, like, I don't know, 200 years from now, you could say, look at the diamond and then put it in this whatever De Beers, the fancy machine, and say, like, boop, put it there, and then, like, pops your entire history of the life the person lived.
Maybe they can put some barcode there, and then search the data from Google. Then
I think DNA, you can in a DNA structure you can store quite lots of data. So
yeah, and it stores.
maybe that's possible someday.
Yeah.
Like if you are able to incorporate DNA into diamond, somehow store it there.
I also saw this one thing that you have written here, Sanjay. This carat, the unit of measurement for gold, what carat means there and what carat means here is very different.
Yes. So carat in general about the like weight, it's 200 milligrams. So 5 carat is equivalent to 1 gram. But in case of gold, it's about purity. Like 24 carat, that's what we call 99.99% gold, pure gold.
So I wonder what happened there. Like, why did they, mess up this? Like, using the same name for different
Maybe
things.
we can.
I mean, it could
search
be. Yeah.
for that particular
Yeah.
thing.
I was wondering, like, maybe we have this whole thing about the imperial measurement system and how they are doing this.
Or there might be like in diamonds, like there is no any possibility to make any impurities. You need to make it pure. I don't know.
No. There are purities. For example, the pink diamond or blue diamond, whatever this shade the diamond gets, that's out of because of the impurities
Okay.
there. And actually, that makes it more valuable. Whereas in gold, if it's impure, it's less valuable.
So one fact about blue diamonds, they said that the blue diamond is natural semiconductor.
Yeah, but
by some definition, but
then
can you make
semiconductors-
use of it to create, make a, another, CPU chipset?
I think you can. It is in the same column of periodic table as silicon. So carbon is in the same column as silicon. So in principle, it can act as like a semiconductor. But then carbon also has other properties depending on like how it is shaped. It is a very bad conductor sometimes, and it's a good conductor sometimes because of this.
Yeah, but for silicon, what we do is like
We have to dope it.
It's a controlled doping of the
Yeah,
impurities.
yeah.
But on diamond, this blue color
It will be much more expensive.
Yeah.
And it's the hardest substance, so I guess to make the.
But now we
shapes.
have this laser cutting. It goes through everything. I think that's what they use, right? Laser cutting. Even in the Surat, like this whole industrial complex that is dedicated to making polishing and making diamond shapes.
Yes.
Yeah.
Well, I lived here for 4 years, but I never went to any. But I heard like
Wait,
90%.
you lived in Surat for 4 years.
Yes.
Yeah, he was studying there.
Okay.
I was studying my bachelor's there. So, well, Surat was quite popular for quite many things because it was quite popular for the textiles. It was quite popular for the diamonds. So there are lots of business people there in Surat.
The Surat is also known as diamond polishing capital of the world.
Mm,
Yeah.
yeah.
Yeah, all the know-how are there from centuries. So at least they have been able to preserve their know-how. They haven't exported anywhere than Surat.
Mm.
That's where I also knew about when I was checking this sort of diamond industry, and then they were quite worried, like okay, this kind of industrial diamonds are coming and they are taking over their jobs. So now the Indian are also quite active on this kind of artificial diamonds. So how to differentiate between the natural and the artificial one. They have been now providing that kind of services as well. So new.
Yeah, but even if you produce the artificial one, the polishing, shining them would still apply, right? Because when you curate it, it doesn't magically become into that, shiny shape, right? It also probably becomes in a really deformed
Maybe it's
space.
much more controlled than the natural ones.
Yeah, I think it's more about the ornamental value comes only when it's shining, and for ornamental uses, people prefer the natural diamond. And but now, if people, is there? You never know. Like the diamond we bought might have been artificial because we just trust the certificate that the shop provides, right? It's like
You may
an
never
honor
know.
system.
But until there was some report like until 2013, only 2% of this diamond in the market were artificial.
2%.
Yeah.
Okay.
But that might have changed now.
But for the industrial use cases, I think that's a lot, right?
Like
But
for
for-
polishing it.
Yeah.
Or
But as we
something.
discussed, like if we are from the middle class, if for the middle class populations, like if it is as good as original diamonds, then and if it gets cheaper, half cheaper price, then why don't we buy them? Because the same thing is happening in Nepal as well. Like you are buying the gold, but now you can buy the the gold material as good as gold. So why don't we buy
Fake
that
gold.
one, the fake golds?
So-
Because for gold it was quite easy because it has the value. So even though you buy it, you know like okay, it will retain the
It
value.
retains the value, or even it appreciates.
Appreciate,
many times.
but for
It is an
diamond,
investment.
Yeah, it is. It's an investment.
for the diamond, it would be to spend your couple of months of
Well,
salary.
if you remember back in our childhood, there were lots of movies where a rich guy converts their property value into diamond and then transport it from one place to
Yeah.
another.
Yeah.
Like there's a rich businessman in London. of Indian origin, and they sell everything and convert it into diamond and come back to India.
Yeah, just,
And
yeah.
it gets stolen.
Yeah, and the whole story revolves around
Oh,
that.
yeah.
Or this Finnish guy, Mad Venture guy. He when he was traveling, he had this one diamond put soon inside his skin, just to make sure that he has some way, some means.
Yeah, also in
for
this movie,
emergency.
Blood Diamond, Leonardo had some
on the
diamond
teeth.
inside it.
Yeah. So in a sense, I guess you can get some money out of it, of course, but it does not retain as much value as gold. But also, gold is a metal. You go through metal detector, it is detected, right?
And it's
And
heavy.
this is carbon. So
Yeah, this is carbon, so
it may
it's-
not
it-
even
yeah.
appear in X-ray machines.
Yeah, so from that perspective, well, I don't know how that happens. Yeah, but yeah.
We are again diverting into this criminal mindset.
It's easier to smuggle, yeah, right? So it's kind of, yeah.
We are not giving ideas.
Yeah, interesting. Yeah. So diamond future, you never know what will, how it will evolve. This the De Beers and the marketing campaign of this. What is it called? A group of people. Cartel. Yeah, this cartel. If that will hold, just like if the Santa Claus myth will hold that Coca-Cola has built for its use.
Same thing goes with this wedding ring with the diamonds as well.
Yeah.
And diamonds are forever. So there has been this kind of commercial advertisement which has filled everyone's mind like, okay, I need to buy diamond if I want to make someone
Happy. Yeah, that was interesting way to see the diamond industry. But for now, I am happy with this carbon-based, air-filled
Now I still need to
crystal.
make these paper cranes to make my dream come true.
And
1,000 of them.
And then,
Yeah.
999 more.
Oh well,
So-
I haven't managed to make one.
Yeah.
Oh wait.
Yeah.
So it has to be the paper crane, and it can't be a paper ball.
No,
Oh,
because
crap.
it's
So I also have to.
auspicious.
All
Crane
right.
is more auspicious.
Crane
than
is
that.
auspicious.
It
All
might
right.
have the reverse effect. So if you have 1,000 of them, then
Yeah, I need to learn that as well.